Hello and welcome to this lesson where we're going to look at M1, the first measurement unit in Math 20-2. And M1 is going to talk about the idea of rates. To start us off, we're going to do a quick review of some of the stuff we've done in the past, and we're going to talk about unit conversions. Because rates are involving a lot of different units, we'll see the definition as we get to part 2. But part 1, we're just going to do a quick refresher of how I can convert one unit to another, right? Centimeters to inches, meters to feet, right? Seconds to minutes. How can I convert from one unit to another for a certain type of measurement? We're going to look at 2 different methods for doing this. They both kind of have their benefits. One might be better than others for certain situations, so that's why we'll cover both. The first way we're going to look at is proportional reasoning. So what that is it's a type of method where we're going to compare 2 equal fractions, right? I'm going to set it up as A over B is equal to C over D, where these 2 fractions are equal to each other. So one side here is going to be our conversion factor, and that's something we're going to hear a lot. That's basically the rule that tells us how the 2 units we're trying to convert are related. So something along the lines of 100 centimeters is equal to 1 meter. Right? 60 seconds is equal to 1 minute. Those equations, right, are those factors essentially that tell us how much we have to change one unit to get to the other. We want to make sure with this that our units are the same in the 2 numerators, so in this case A and C, and in the 2 denominators, right? We're setting these 2 things equal to each other, so we need to make sure things are equivalent. We're then going to solve, right? One of these is going to be our unknown, because we don't know our final unit. And we're going to cross multiply and divide to solve that unknown. And that's going to give us our unknown measurement. So let's see what that looks like. Let's do a couple of examples here. I'm going to convert 290 milliliters into liters. So what I want to do is I want to set up my fraction. I'm trying to get to liters. That's my goal. So I'm going to say X liters on the top. Right? I want to know how many liters there is per, right, for every divided by 290 milliliters. Right? How many liters are there per every 290 milliliters? I'm going to set that equal to something that's true, right? That's going to be our conversion factor. We're going to use the fact that there's 1,000 milliliters, right? That's what the milli means, 1,000. 1,000 milliliters in every liter. So that's going to become the whole second side of my equation. And again, I want to make sure I'm putting per 1 liter, right? I want to make sure I'm putting the same units top and top. So liters on the top of the left side. We need to put liters on the top of the right. And then milliliters is going to go on the bottom. Right? And this is essentially me setting up 2 equal proportions, saying, well, if 1 liter happens for every 1,000 milliliters, how many liters, right? X liters are going to happen for every 290 milliliters. These are equal proportions. Then, to solve for this, I'm going to, like we said, cross multiply. I'm going to multiply that 290 up to the right side. I'm technically going to multiply that 1,000 up to the left side as well. I'm getting 1,000 X, and then 290 times 1. And then divide both sides by that 1,000, right? Trying to isolate X. I'm trying to solve for my unknown. But when I do to one side, I have to do to the other. And I end up getting a result that says X equals, and we look, right? 290 divided by 1,000. I get a value of 0.29. And again, X was in terms of liters, our unknown was in liters. So we're going to put a unit of liters on this. Right? If 1 liter is 1,000 milliliters, this is less than 1,000 milliliters, so it should be less than 1 liter. Let's look at a second example here. I'm going to convert 76,200 centimeters into meters. Again, I'm going to kind of do the same thing. Looking back at that last one, I set it up kind of as what I want over what I have on the left side. And then on the right side, I just set up my conversion factor. So let's use that same idea to set up this next one. Let's take what I want. I want meters. But I want to know how many meters it is out of the centimeters that I already have. Right, the 76,200 centimeters. And that's going to be equal to, how are these things actually related? Well, we kind of mentioned it up here. There's Well, we kind of mentioned it up here. There's 100 centimeters for every 1 meter. Again, making sure my units are the same top and bottom. So meters has to go on the top. Centimeters goes on the bottom. I'm going to cross multiply. And this time we notice if I just cross multiply from the left side to the right, and I don't bring that 100 over, it's going to save me a step. All right, I'm trying to isolate x. So let's just bring that denominator over. You can go for either method, whatever makes more sense to you. I'm left with just x on the left, but then I've multiplied 76,200 up to the top, and there's still 100 on the bottom. So I'm going to do 76,200. I divide that by 100, and that's going to give me 762. And remember, x, my units, was meters. So that's proportional reasoning, right? I'm setting up two equal proportions and solving for an unknown. This is mostly beneficial for when we're only converting 1 unit. So let's look at a second way we can convert measurements. And this second method is what we call unit analysis. So here we're going to essentially analyze the units we have and see how we can get rid of the ones we don't want and introduce the ones we do want. It's going to involve that same conversion factor, right? We always have to use that. That's the rule that says here's how the unit you have and the unit you want are related. But this time, instead of setting it equal to each other, I'm going to multiply. And I'm going to set it up specifically so that I have common units that are on the top and the bottom so that they reduce, right? They cancel each other out. It's essentially a common factor in the numerator and the denominator. And we know that that reduces in a fraction. So that means we're going to be left only with the unit we want. And then we're just going to go ahead and multiply it all out. So looking at the same examples, or the first example is the same at least, let's see what this looks like. So this time I'm going to start my known value. So I'm starting with 290 milliliters. And I'm not setting it up as a fraction just yet. Again, my conversion factor, we're still trying to get from milliliters to liters. So we're still going to use the fact that there's 1,000 milliliters for every 1 liter. But the way I'm going to set this up is I'm going to multiply by that ratio, right? The conversion between the two. But now I want milliliters to show up on the bottom. Because what's happening here is I have milliliters on the top and milliliters on the bottom, right? When we multiply fractions, numerators multiply by numerators, so that milliliters stays in the top. If it helps to visualize it, think of this as 290 milliliters over 1. Right, we have common units in the top and bottom. We can cancel those out. But if I put 1 liter on the top, that means my new units, the only units I have left, are in liters. And so what this looks like mathematically is I'm going to multiply across the top and across the bottom. So essentially I'm doing 290 times 1. And I have liters on the top. On the bottom, I'm doing 1 times 1,000. But I actually have no units left there. And then when I divide 290 divided by 1,000, this should look familiar because that's what we did in our last scenario. I'm getting 0.29. And my units are now in liters. So we get the same result. It's just kind of a different method of getting there. The reason that unit analysis might be used a little more commonly is because it's extra helpful when we're trying to convert 2 different units. So let's look at this one on the right-hand side. I'm trying to get meters to kilometers, And I'm also trying to get seconds to hours. Oops. So let's think about some conversion factors we have. If it's something that's not common, it will be provided in the question or on a formula sheet for you. But meters to kilometers, again, kilo is the same. There's 1,000 meters for every 1 kilometer. And then for seconds, we're actually going to do a couple of steps here. I know that there's 60 seconds in every 1 minute. I also know that I can then go from 60 minutes into 1 hour. So we might have to do a couple of steps here, and we'll see what that looks like with unit analysis. Again, we're going to start with our known value. I know 9 meters per second. So here's our 9.2. I'm going to write this a little different though. I'm going to write it meters per second, or if it helps, we can think of this as 9.2 meters for every 1 second that passes. This is what we call a unit rate, which we'll see more in our next part. So that way we can really see, right? Meters are on the top, so I want to cancel those out by getting them to show up on the bottom. Seconds are on the bottom, so I actually want to cancel that out by getting it to show up on the top. So first things first, and we can start with either. We need to do them one at a time though. Let's go meters to kilometers first. So meters, again, I want that to show up on the bottom so that I can get rid of it, right? So that meters can cancel out across the top and bottom. Things can't cancel out side by side, but they can cancel out numerator and denominator. And we know that that's equal to 1 kilometer. Again, this has to be my conversion factor, right? I have to be stating a true statement. There is 1 kilometer for every 1,000 meters. So we're good on 1 unit. I'm successfully in kilometers in the top of my fraction, which is what my final goal is. Now I need to work on those seconds, right? The time unit. Right now, seconds is on the bottom. So first, as I'm converting to 1 minute, I'm going to put seconds on the top so that, again, opposite sides of the fraction, they can cancel each other out. And that's for 1 minute. So if we look right now, technically I'm in kilometers per minute. But I want to get into kilometers per hour like the question said. So I set up another conversion factor where this time minutes goes on the top because now that's what I'm trying to get rid of. And hours goes on the bottom. So minutes have now canceled out. Notice my only units left are kilometers on the top, hours on the bottom, just like my goal. Now for this, I'm going to multiply every numerator by every numerator, and same thing in the denominator, right? When I multiply fractions, I multiply straight across. So my numerator is going to look like 9.2 times 1 times 60 times 60, right? All of my numerators multiplied together. And the only units left up there were kilometers. Denominator, I'm going to do 1 times 1,000 times 1 times 1, right? And some of these ones are pretty redundant. You don't need to write that out. When I multiply those all together, I get 33,120 kilometers for every 1,000 hours that passes, and that's a very long trip. But if I divide by 1,000, that turns into 33.1 kilometers an hour. All right, so we turned meters per second into kilometers per hour by changing both of those units. And this is where unit analysis can be beneficial, because if we were doing proportional reasoning, we'd have to do each of these individually. I'd set up a proportion to convert meters to kilometers. I'd set up a proportion to convert seconds to hours, and then I would divide those two values, right? Essentially, I would get to this value at the end, right? So there's some examples for you to try at the bottom. Take a minute, pause, give those a try, and I'll put the answers up for you here in a minute. All right, so if you've given these 4 examples a try, these are the values you should be getting. If you're struggling with any of those, feel free to send your teacher an email or ask down in the comments below. Hopefully that's a good review for you to refresh your memory on those unit conversions from Math 10C. Again, whichever method you prefer, feel free to use. However, unit analysis is going to come in a lot more handy when we're dealing with multiple units. And it is the method that I will likely be using for the examples carrying forward. So come back for our next video, part 2, where we're going to start to actually look at what our rates get into the unit for Math 20-2. And I will see you in the next part.